Hey guys, it's Miss Silva. We're going to start Unit 1 for this lesson, and Unit 1 has to do with Introduction to Functions. Now, for the first lesson, we're going to be distinguishing between functions and non-functions and identifying each of the functions that we'll work with throughout the year. So let's go ahead and get started with our first lesson. The learning target is I can distinguish between functions. Now, what is a function? I'm sure this is not the first time you've heard of a function. You started it in Algebra 1. A function is a relation where every input has exactly one output. Let's go ahead and write that part down. If you need a reminder of what an input is an x value, output is a y value. Now, what does that mean? That means if we have an equation, let's say it's 2x plus 1, and we have an x value. We're going to create a little table here. We have an x value of 3. That means we're going to substitute this x for 3 and then solve. And that will give us our y value, which is 7. So no matter what, if we input that x value of 3 into that equation, we can only get 7 as our output. Another example would be, let's say we input 0. Let's go ahead and put 2 times 0 plus 1. 2 times 0 is 0 plus 1 is 1. So the only y value we can get when we input 0 would be 1. That's what it means that for every input, there's exactly one out. Now, there are different ways that functions are represented. The first one is a table. Now, from a table, we can distinguish whether or not the relation is a function by looking at the x values. So, for example, if we input x, 1 for x, then our y value is 1. If we input 2, our y value is 4. If we input 3, our y value is 9, 4, 16, and 5, 25. Notice how every x value has exactly one y value. This would represent because every x value has exactly has exactly one y value. All right, let's look at the second example. We have a table here. Notice how this -3 as an x value has a y value of 0. But if you look further down, there's another -3 in that x column, but that y value is 2. This represents a non-function or not a function because -3, when x is equal to -3, the y is equal to 2 or 0. A good rule to remember for tables is there are no repeating x values. There are no repeating x values. Let's just write x does not repeat. Okay, let's go on to the second type of representation, which is graphs. Now with graphs, we use the vertical line test. Now if it passes a test, then it's a function. If it fails the test, it is not a function. Now let's go ahead and see what that means. I'm going to draw a vertical line and notice how it only intersects at one point, which means this point, the x value for that point has exactly one y value. Anywhere I draw a vertical line on this graph, it will only intersect one, which means this, because it passes a vertical line test, which means it is a function. Let's go on to this next example. Now, if you notice, if I draw a vertical line here, it's passing that vertical line test, but if I were to draw the vertical line here, we have 3 points where it intersects, which means that it fails the vertical line test. And because it fails the vertical line test, that means it is not a function. Now, why is that so? Well, if you notice these 3 points, they all have an x value of -3. But here, it has a different y value, this point has a different y value, and this point has a different y value, which means that x value has more than one output. So for graphs, again, we use our vertical line test. Now let's go on to mapping diagrams. Mapping diagrams are very similar to tables, except we use arrows to map each x value to the y value. Now, if you look at this first mapping diagram, -1 maps to 2, which means -1 is my input, 2 is my output, 1, 2, 1. The 0 maps to 2. 0 only has an output of 2, so we're still good. 1 maps to -3, 2 to -2, and 8 to 3. In this case, only 1. In this case, we have a function because each x value has exactly one y value for each input. All right, let's go ahead and look at this mapping diagram. Let's look at 2. 2 has 2 arrows coming out of it. It's mapping to 20, and it's also mapping to 40. So this one input has two outputs. Then because this input has two outputs, it automatically makes it not a function. So this is not a function because 2 has 20 and 30 as it, I'm sorry, 40. 20 and 40 as the output. So for the mapping diagram, one rule we can remember to use is it is a function if there is only one output. And remember those mapping diagrams, they're arrows. So only one arrow out of each input. All right, so now let's look at ordered pairs. Ordered pairs are like tables. We have X and Y for each ordered pair. Let's go ahead and circle all our X values. And all those X values are different, and they each have their own unique y value. Therefore, this is a function. Now, if we look at the next one, right away we can see that these two inputs have different outputs. Therefore, it is not a function because -2 has outputs of 1 and 3.